Now with this final exercise, volume and surface area of composite solids, there's no new maths, there are no new formulas. It's a little bit like the area of composite shapes. It just depends on the previous formulas that you've learned. And being able to recognise different solid shapes this time being put together. So it says composite solids are simply combinations of known shapes. So it must be up to you to recognise the shape, access the correct formula, and just like I've said, volume and surface area doesn't involve any new maths, but it does require careful reading, attention to detail, and sticking to a plan, identifying the information you've got, writing down what you're finding. These are all problem-solving techniques. Okay, let's have a look at the example on the next page. So, okay, in this example, you'll really have to read very carefully because there's quite a bit of information that if you don't register, then you'll find it difficult to get the right calculation. So the concrete block shown is a square prism with a cylindrical hole, diameter 10, drilled through it. So A wants for the volume before drilling, B is the volume after drilling to the nearest centimetre cubed, and C is a percentage question. What's the percentage, correct to 1 decimal place, of the concrete that was removed to make the hole? Let's have a look at the block, the diagram. What information can we get out of that? Combined with the written information, it's telling us it's a square prism, so you can probably see that the 30 by 30 creates the square, and the 12 would be the height, because we're thinking along those lines, because the volume of a prism is A times H. The cylinder, think about the cylinder that's been taken out of the middle, cylinder running right through it, would be, that's a very good diagram, has a diameter, so note that the diameter is 10. In our calculations we only use the radius, so we need to be aware of that. Okay, let's move on and show the working for A. What was the volume of the concrete block before drilling? The volume of any prism is A times H. This is a square prism. The area will be side square because that's the area of a square, and times the height of the prism. The square we can see from the diagram is 30 by 30, and then that leaves the 12 for the height. And that gives 108.00 centimetres cubed. B wants the volume of the concrete block after the drilling to the nearest centimetre cubed. So we know that a cylinder is being taken out of the middle. Let's work out the volume of the cylinder. The volume of a cylinder is pi r squared h. We've got pi times the radius here. We've noted the radius is a 5, and the height of this would be 12. The cylinder would run for 12 centimetres through. Now, just having a look at the calculator, pi times 5 squared times 12, 942.47, it does say to the nearest centimetre cubed, and remember this is only the volume of the cylinder, the amount that's been taken out. So the volume of the concrete block after the drilling would be what it was, subtract what's been taken out. And you get 9858, the 10,800, subtract 942. C. What percentage, correct to 1 decimal place, of the concrete was removed? So the percentage removed. Remember, before you get a percentage, you must have a fraction. We want the amount removed over the total. That will create our fraction, and we multiply by 100. So the amount removed was this 942. The total that was originally there was our 10,800, and we multiply by 100. And that is our 942 on 10,800 multiplied by 100. 8.72, repeating, to 1 decimal place will be 8.7%. Should be right to make your summary and key points and do exercise 511.